The letters of the word counters are to be arranged. In how many ways can this be done? In how many ways can this be done if it begins with a C, and then if O and U are separated, and finally what is the probability that the arrangement contains the word count? So to start with, the word counters has 8 letters, and so there are 8 spaces available for us to arrange these each of the letters, and therefore they can be arranged in 8 times, 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1, and that is factorial 8 ways, and that is 4320 ways. The next part, the B part, in how many ways can this be done if the word begins with a C? So if the word is to begin with a C, what it means is the first position is fixed. So you can't change that. No other letter would be allowed here, only C, and one place is already taken. So the rest of the places, there are 7 more spaces, and so those 7 spaces, C is fixed, so those 7 spaces can be taken factorial 7 ways. So the answer would be simply factorial 7, and that is 5040 ways. The next part is how many ways can this be done if the O and U are separated? So that it can be answered by considering the case where O and U are put together and subtracting the number of ways O and U are put together from the total number of ways, that is 4320. So the number of ways O and U can be put together, and that's what I wrote there. So you consider the case when O and U are together, and the answer is total number of ways minus the number of ways when O and U are together. So O and U are together, so therefore you can take the first and second place in one way, the second and third place, third and fourth place, fourth and fifth place, fifth and sixth place, sixth and seventh place, and seventh and eighth place in 7 ways. Now you can take the place in 7 ways, but O and U can be interchanged. They can take each other's place, so they can change position in 2 ways. So the rest of the letters can be arranged in factorial 6 ways, because if you put O and E, there are 6 places that remain vacant, so they can be arranged in factorial 6 ways. So the total number of arrangement when O and U are together is 7 times 2 times factorial 6, and that is 10080. But this is the number of ways in which O and U are together. We have been asked when O and U are separated, so we got to subtract this number from this 4320, and what we get when we do that is 30,240 ways. So 30,240 is the number of ways in which the letters can be arranged so that O and U are separated. The next part, the part D, for this we have to work out the probability of the arrangement that contains the word count. So we have to find how many ways you can arrange the letters when the word count as a whole exists. So count again, once more, count can take 1, 2, 3, 4, 5. It's 5 places in only one way, but then it can move considering it's all together. So count is one way. Next, it can take the next 5 places in, and then it takes the next 5 and next 5. So finally 4 ways count can be together. If you think of them like staying together, the 4 ways they can take up the 8 places, so they're together. Now they can't be rearranged amongst themselves, then it will not be count anymore. So there is only one arrangement between themselves. They have to place C first, U next, O O next, U after that, N and then T. And the remaining places are 3 places, so they can be arranged in factorial 3 ways. So therefore the number of arrangements would be 4 times factorial 3, and that is 24 ways. Now once we know the 24 ways, the probability will be 24 divided by the total number of arrangements possible, and that is 24 out of 4320, and simplifying it, it will give you 1 out of 1680. So that's your final answer for the part D.